Hello, this is ECAA 2017 question 35. So in this question we're told that the graph of y equals fx intersects the x-axis at exactly two distinct points. And we're told to consider these following graphs, and they ask how many of these necessarily intersect the x-axis at exactly two distinct points. Okay, so these are a list of functions that we're considering, and our graph is going to look somewhere like this around the points where it intersects the x-axis. So it might, it doesn't really matter what it does after that, but we know it doesn't cross the x-axis again because it only crosses in two places. Okay, so for this first one, f of x plus 2, well, that's just this curve but moved up two places. So if we move this up, depending on how the scaling is on the y-axis, we can see we could easily move this up two places so that it was all above the x-axis, and then it wouldn't cross anywhere. So this first one doesn't necessarily have to cross the x-axis. Now for f of x plus 2, this is moving the graph left two places, and we can see that it doesn't matter how far we move this left, there's still going to be two places here and here that cross the x-axis. We're just shifting the points at where it crosses to the left as well. So this one would have two distinct points that cross the x-axis. Now for this third one, this is a stretch in the y direction by a factor of 2. But at these two places where f of x crosses the x-axis, so f of x is 0, on the original graph, so when we stretch it, f of x is 0, so 2f of x is still going to be 0. So where it crosses in the original graph after we stretch, they're still going to cross. So this one would cross the x-axis in two places. Okay, now for this fourth one, so this is a reflection in the x-axis, and then we shift up by 2. So this depends on what the rest of the graph looks like, but if we had something like this, so we have a couple of maximum points, and it doesn't ever cross the x-axis again. But then if we reflect this, and now we move it up, we could move it up two places so that these, what used to be maximums and now minimums, lie above the x-axis, and now it doesn't cross anywhere. So this one doesn't necessarily have to cross. And finally, for this last one, it's a reflection in the x direction, and then a stretch in the x direction, so it becomes thinner, so it looks something like this. And you can see that when we reflect it, we still have the 2 points where it crosses the x-axis, because we haven't moved up or down. And then when we stretch, these points just moved in. So we are still going to get 2 places where it crosses the x-axis, so that's another tick. So all in all, we've got 3 of these graphs where they have to have 2 distinct intersections. So we have solution D.